Hi class, in this video we're going to go over how to set up SSH servers. So before I begin, I'm going to deactivate my lab and activate it again. This will give me a clean lab environment. I like to do the IP settings a few times so it sinks in. So that's why I want to reset the lab, so we have to redo the IPs. So it's now activated. I'm going to boot up each server. And then I'm going to go to console for server 1. I'm going to pause the video while it's booting up. I'm going to sign in as student with our standard password, capital PA11WORD. Open up a terminal, and then sign in as root. Don't forget to use the hyphen because you won't load root's profile. Okay, so I'm going to do nmcli connection add connection name. I'm just going to erase this for 1 second. I'm going to do IP adder, and the connection name I'm going to stick with the actual physical device name, which is ENS5. I believe that the book uses static. nmcli connection add, connection name is ENS5. The interface name that I'm going to associate this connection with is ENS5. This is the physical device. The type is Ethernet. The IPv4 address is 10.0.0.2/24. I don't know why I did that. 24, it's a /24 for ACE-IT Lab. The gateway is 10.0.0.1. The IPv4, sorry guys, I messed up here. This is just IP4. The IPv4.DNS, I didn't hit enter, it just word wrapped to the second line. There's no space between my two DNS servers. Auto connect is yes, meaning every time this computer reboots, automatically connect to this network. And just as a failsafe, I'm going to do IPv4.method is manual, so we don't have that problem we had last time. If you mix these terms up, it might not use your static IP. It might still be DHCP. So to avoid that, we're just going to manually sorry, I put 10 twice. We're just going to force it to be a static IP and not dynamic. I'm just going to show you what I'm talking about. cat etc sysconfig network -scripts ifcfg, and then the name of your connection, which is ENS5. This command created this file, so I'm going to look at the file. So that method right there, where we said manual it made this boot protocol to none. If you didn't do this and this order wasn't correct, this might have said DHCP, the boot proto. So to avoid that, we just added that line so we know that it'll automatically change boot proto to none. It won't leave it at boot proto equals DHCP. I'm going to do NMCLI connection show. I can see my connection is green. It's up and running. If it wasn't green, if it was white, I would do NMCLI connection up ENS5. But it was already activated for me. I can see it was done up here too. Okay, now I'm going to do IP adder again. I can see I now have my static IP. Everything is working well. If you want, you can test with a ping. That worked. I'm going to press Control C to stop the ping. I'm going to do host to verify that I can resolve names, and I can. This is a utility to test connectivity. This is a utility to test DNS. Okay, now I'm going to set the computer name. Host name, control, set host name to vm1.lennox.com. It's just a fake domain name. I need to always resolve this this name to an IP. If my network goes down, I still need to be able to resolve this name to an IP. So what I'm going to do is locally resolve it to my loopback address, because this interface can never go down. This one is connected to a real network. If it goes down, you might not be able to resolve that name. But your loopback interface always points to your own machine. So I'm going to use this IP address to resolve it to this name. Normally, DNS is used to resolve IPs to names and names to IPs. But before DNS, we had something called host files. I'm going to stick to my host file. So I'm going to edit my host file, vi etc host. Before your computer contacts a DNS server, it looks in this file to see if that name can be resolved to an IP. You can change that, but by default, this is where it looks before it consults DNS. I'm going to go to the bottom, hit a lowercase o to go into insert mode below my current line. And I'm going to vm1.lennox.com. So the long and short name are being resolved to the loopback address, the fully qualified domain name, and my host name. I'm going to do the same thing for IPv6. vm1.lennox.com. And then, just to save me some time, I'm also going to fix up this host file so I can resolve vm2.lennox.com when I get that machine configured. So 10.0.0.3, eventually that's going to be the IP address of VM2. Sorry, I had a typo here. Now, some services depend on this name being resolvable to an IP. Otherwise, it might prevent your machine from booting. But if we can't resolve this because our network is down, no big deal. But this one, we always have to resolve to an IP. So there is my IPv4 loopback address. There's my IPv6 loopback address. We really don't control the DNS servers, so just to make my life simple, I'm also going to resolve the IP 10.0.0.3 to VM2. So I'm going to press escape to go back to normal mode, :WQ to save and quit. Then after I rename my computer, I need to reboot so that name sticks. Right now, my name is still localhost. Until you reboot, it won't reread that file. When I did that hostname control command, it edited a file called etc hostname. So there's my host name. I can see that it's set. I'm going to sign in as root. You can also run the command hostname to see your computer name. So now I'm going to jump over to Red Hat Server 2. I'm going to drag up from the bottom, sign in, set the IP address, and hostname. Open up a terminal. Sign in as root. I'm going to do IP adder to look at my interfaces. And I can see this network card is ENS8. We're getting weird network cards on ACE-IT Lab. Normally it's ETH0, ETH1, ETH2, things like that. I'm not sure, because we're hosting these virtual machines on a Linux box. I'm not sure why it is labeling them ENS5, ENS8. I'm sure there's a valid reason. I just don't know what it is. But so I'm just going to stick with the name they gave me. Normally, it creates an alias and refers to the alias. So whatever network card driver that you use, it makes an alias called ETH0. I'm not sure why it's not making that alias. I'm sure there's a valid reason. Again, I just don't know what it is. So I'm going to do nm CLI connection add connection hyphen name. Guys, and I could type out the full name. I'm just abbreviating these. So just to keep it simple. It's really connection, but I just type con. Connection name is ENS8. My preference is I like to keep my profile to my connection name to match my physical device name. That's my physical device. You can do nmcli device show and look at your physical devices. Kind of think of this as a profile. When you have a wireless card and you're connected at home, and then when you go out and you connect to Starbucks, it's still the same physical card, but you have two different IPs. Well, that's because they're done with profiles. So when you look at your wireless interface, you might have a lot of network profiles. Kind of think of this as the same way. So interface name, the physical device I'm associating this profile with is ENS8. It is a Ethernet type card network. The IP 4 address will be 10.0.0.3/24. The gateway for that network, the router, is 10.0.0.1. I'm not hitting enter here. It's just doing word wrap. The DNS servers for this network are 10.13.2.5, 10.13.2.7. I want this to automatically connect to this profile. Guys, you should only have one auto connect being yes for a physical device. So if I have 4 profiles or 4 connections for this physical interface, only one of them should be auto connect equals yes. So when you boot up, you can't connect using 2 or 3 different profiles. You can only do one profile. And just as a fail safe, I'm going to do IPv4.method and change that to manual. I had another typo. Believe it or not, guys, I don't have any Windows laptop or anything I can do recording with. I'm using my wife's laptop, and it's this Lenovo. It's a really good computer, but the keypad, they kind of move the keys around. I don't know why they would do that. The shift key's in a different place. It's just the weirdest keyboard layout I've ever seen. And it's taken some getting used to. Okay, I'm going to do NMCLI connection show, and I can see it's up. I can do IP adder and see that I have my static IP. Now I'm going to change my host name. Maybe that wasn't it. It's set host name. Okay, now I'm going to resolve that name to my loopback. vm2.linux.com. This is just for local name resolution. I'm also going to do the IPv6. And I'm also going to resolve VM1 while I'm here. I'm going to press escape. Guys, I clicked O to enter insert mode. So now I'll press escape to get out of insert mode. Shift:WQ. Save and exit. We're going to reboot so our name change takes effect. Okay, now our IPs are set. I'm going to go back to server 1. So I'm going to use this as a SSH client, server 1. And I'm going to use server 2 as an SSH server. An SSH server allows me to remotely connect to a Linux machine or any machine running an SSH server, because now you can actually get SSH on a SSH server on a Windows box. It allows me to connect to that machine using a command line interface. Like everything, there's a server and client. A lot of times people will connect to Linux servers from Windows boxes. And if that's the case, they might use some utility like this to connect from the Windows box. So this will be the SSH client, and the SSH server software will be running on the Linux box. Here's another one I just recently played around with. It's called Snowflake SSH client, which you can put on a Mac or a Windows or a Linux box. So there's a bunch of different clients out there, but there's also one built into the command line interface. So it allows me to connect remotely to another machine. So right now I'm going to use server 1 as my SSH client and server 2 as my SSH server. So I'm going to go into SSH VM2, or I could do vm2.linux.com, my fully qualified name. The reason why this will work is because I can resolve that name to an IP. If you couldn't, you might have to type the IP. In either case, it doesn't really matter how you connect. The IP of server 2 is .3. I don't care what name you use or IP, I'm going to use VM2. So I'm going to connect from this machine to that machine. Now, right now, I'm not supplying any user account information. So it's just going to use my current user account name. So I'm signed in as root, and we can see that right here. So it's going to sign me in as root on the other box. So SSH VM2. And the first time that I connect, it's going to ask me to download the server's public key. The server has two keys, a public key and a private key. Anyone can get the public key. I'm going to type yes here. And then it's asking me for the password. Anyone can have the public key, and only the server will have the private key. When you install the SSH server and boot it for the first time, it creates that public and private key pair. They're created together. If your private key gets compromised, you have to recreate a new private and a new public key. You can't just create the private key because they're always created in pairs. So when the server encrypts something and sends it out, at that point, anyone with the public key can decrypt it. And that's not security. All that's really doing, anyone can decrypt it. As long as they have the private key, the public key of the server, anyone can decrypt it. It's called non-repudiation. Basically, it came from VM2. You're talking to the right server. You're not talking to some kid's, hacker little kid's basement server. A phishing attack. Like if you go to a server that you think is your bank server when it's really not your bank server, by using certificates or public and private key pairs, you're talking to the right server. Because I have the public key for VM2. When VM2 encrypted the data with the private key, I was able to decrypt it with the public key. So then I know I must have been talking to the server that I want. And right now, I'm going to be using my passwords to encrypt packets going back to the server. The server will decrypt it with my password that it has stored locally, and at that point, we'll have secure communication at that point. It takes something at both ends to be secure. If only one end had like a public and private key pair, and at that point, it would be just non-repudiation. Anyone would be able to interpret those packets. But I'm going to be using my password to encrypt stuff when I send it back to the server. And since the server knows my password, it'll be able to decrypt it. and at that point I'll have secure communication. So if you want to read up more about this, you want to look up public key infrastructure. This concept. Read this right here. PKI, public key infrastructure. All of our SSH certificates are public key. Also, the SSL certificates we use for web pages is the same concept. So it's a pretty good read. So I'm going to go back to my server. So now I am connected to VM2 as root. So you can see that I'm connected remotely. I'm signed in as root. So if I type exit, I'll disconnect from VM2. So this will allow me to manage those other machines remotely without having to go to the keyboard. And remember, some of these machines don't even have a keyboard. Some of these servers are in racks otherwhere, so I need a way to remotely manage them. So I could connect using a name, sign in as a different name. So I'm going to do SSH. Right now I'm disconnected from VM2. I'm connected locally to VM1. So I'm going to do SSH student. So I'm going to sign in as student on the other machine this time. Student at VM2. So now instead of logging in as root, meaning my default account, I'm going to specify which user account I want to log into on that remote machine. So I'm going to hit enter and type in student's password. Notice it didn't prompt me to store the public key this time because I've already saved the public key. I'm signed in as root on my VM1. So when I connect it to a server once, root will save that server's public key. So when I sign in as a different user on that remote server, I still have the public key from the first time I signed in as root. So again, I'm connected remotely as the student account. So I'm one connected to VM2 as student. So I'm going to exit again. I'm going to do a list dash long, which basically will show me all hidden files and the permissions. So again, anything starting with a dot is a hidden file or folder. So I have this .ssh folder. Sorry, this .ssh folder. Let me highlight it. Notice the permissions. The only person who has permission for this folder is the user owner, which is root. If these permissions are too relaxed, meaning root the group has permissions or anyone else in world has permissions, then the SSH server or your SSH client won't trust these keys. If these keys get out, you don't have any sort of security. So it's very important that this folder remains secure because it contains a bunch of public and private keys. So I'm going to list.ssh to look inside of it. So right now I know I have one file in there called known host. Anytime I connect to a server from this user account, it's going to store that server's public key in that file. So I'm going to cat that file. I hit the tab key to complete. So right now I only know about one server, VM2. It gives the IP address, and right there is my public key, and it also states what type of encryption it's using. I'm going to do this. SSH. I'm going to connect, sign in as student on the other machine. But this time I'm going to use vm2.linux.com. I'm going to connect using the fully qualified domain name. Look, it's prompting me to save the key again. I'm going to hit yes. Sign in once. So now I'm signed in remotely to the other machine. I'm going to type exit. Now I'm signed back into VM1. Now I want to look at this file again. When I signed in as the short name, it stored the public key from the server. When I typed in the long name, it created a new entry because these two names don't match. So if you sign in with the short name or the long name, it's going to save that key twice. Let's do this again. But this time I'm going to do SSH, student, and I'm going to type in the IP address of VM2. See, it didn't prompt me for the key. Because if you look in the host file, it saves the IP there. So if you refer to a server with multiple different names, it's going to create an entry in your known host file for each of those names that you use. But if you use any one name, it's also going to store the IP address for those machines as well. So, that's fine. The first time you create an entry for a machine, it will save the IP address automatically. But if you have multiple names for a machine, and that's relatively common, at that point it's going to save an entry for each name. Be aware of that. Okay, so right now we're able to sign in remotely from our SSH client, which is on server 1, to server 2. Now, if I look in this folder again, .ssh, sorry, I didn't put the dot. It only has one file, list SSH, that's my folder. If I list all along, I have a folder called SSH, and inside that folder I have a file called known host. So right now, every time I sign in, I'm signing in with a password. I'm supplying a user account name and a password every time I want to sign in. And it's using that password as part of my encryption method. What I can do if I want to do something more secure is create a public and private key for my user to sign in. So when I sign in, I don't have to supply a user account name and password. So I'm going to do a command called SSH Key. It took me a minute to remember the command. SSH Key Jen. This is going to generate keys for my user account called root. What's really important to understand that there's two user accounts involved. I have a user account that I'm signing in. This is going to be the user account called root on VM1. When I sign into a user account called student on VM2. So right now I'm creating a key, a public and private key for root that's on VM1. So it's asking where to save the file. Under my root's home folder, the .ssh folder, and it's going to create a public and private key for the RSA encryption type. Again, this folder is secure. Only person who should be able to read it is my root user account. This is root's home folder. This is the folder where I keep my keys. This is what this is what the keys will be called. We'll look at them after the fact. I'm going to hit enter, enter. I'm not entering a passphrase, because if you enter a passphrase, it's just going to prompt you every time you want to sign in. Now I'm going to do list.ssh. Now I have 3 files. I have my private key and my public key. So just like my server, now my user account has a public and private key. So when I encrypt something with my private key, anyone who has my public key can decrypt it. And also, if someone sends me something, they can use my public key to encrypt it. And when they send it to me, I'll be able to decrypt it with my private key. The only key that will be able to decrypt those packets is my private key. Again, do that, read that information about public key infrastructure. So if someone encrypts something with a public key, the only key that can decrypt it is the private key. And I should be the only one who has that private key, so that makes it secure. So now I'm going to, I need to distribute this public key. Because right now, I'm the only one who has it. So for the server to encrypt stuff with my public key, I need to send that key over to the server. Okay, but what I'm going to do is associate this public key of mine. I'm going to copy it over to the student account on VM2. So when I sign in, it's going to sign me in as student on the other end. So I'll be root at this end. When I sign into the server, I'm going to be signed in as student. So I'm going to copy. No, I'm not. I'm going to do SSH, copy, ID to student at VM2. So I'm going to store my public key under the student's home folder. So when I sign in to VM1, I'm going to be signed in as student. So I'm going to copy my public key. Before I copy it, I'm going to sign in the student and show you. So I'm going to SSH student at VM2. I'm going to supply my password. And if I do a list A long, I could see I don't have any SSH folder yet. Because from student, I've never, as a SSH client, I've never connected to a server. I didn't create any public or private keys for student on VM2, so there's no SSH folder yet. So I'm going to type exit to go back to VM1. So I'm back on VM1. So I'm going to do SSH, copy, ID. I'm going to copy my public key for root over to the student account on VM2. It's asking me to sign in with my password, and you can see that I copied this key, root.ssh ID _ SSA pub, my public key, over to the other server, and saved it in the student account. So if I type SSH student at VM2, normally it would prompt me for a password. But now that I've copied my public key over to the other machine as student, it'll automatically try to use keys before password. And since I have the key set up, it'll sign me in automatically. So I'm going to hit enter, and it didn't prompt me for a password. So when I sign in from root on VM1, the client, to server VM2, my SSH server on VM2, as student, it won't prompt me for a password. So I'm going to do a list. So I'm signed in as student right now on VM2 right here. Now I have an SSH folder. If I do a list, I can see I have a file called authorized keys. So this is going to be a file that stores all of the public keys that I know about from all my different user accounts elsewhere in the network. So right now, it's only going to know about one key, the public key for the root user account on VM1. So if I go to another SSH client, that other SSH client will have its own user account. Let's just say my desktop machine or something like that. And then my user account name on my desktop will be Brian. So I would create a public and private key for Brian, and then I would copy that public key over to this machine as student. So it would have an entry for my desktop machine and the Brian user account. So I'm going to cat.ssh/authorized keys. So there's my public key. It's an RSA key for this user account on that machine. I might have a user account, a root account on a different server. Each user account will have its own public and private key. Even if the user account name is the same, like let's say I had a VM4. The root user account on VM4 is different than the root user account on VM1. So it's going to create an entry for every single client, every single user on every single client, as long as you manually copy them over. So I'm going to exit off the VM2 and sign back into VM1. So guys, why do we want to use keys instead of just a password? First, it's more secure. A key is going to be a lot harder to crack than a password. And number two is I can automate something. I can use SSH to automatically go at a certain time to connect to a server and do some task. If I have that task done at 4 o'clock in the morning and I only use passwords, at that point, I'd have to be there to supply my password. With keys, I can actually automate that and just, once I have my key copied, I can just run and it will automatically use my key. I don't have to be there to use my key. So it really makes a lot of difference whether you use keys or passwords. First is keys are more secure. Secondly, I can automate. In my script, I can do something like I'm going to do SSH -- help. This is my SSH client. I have this, let me find it, thing here at the end called command. So I can use SSH to run a command automatically. Let's do SSH student at VM2. Now remember, for my root user account, I took my public key and saved it over to the student user account on VM2. So it won't prompt me for the password. If I try to take and sign in as root at VM2, I've never associated my key for this user account, root on VM1, with a root on VM2 account. So it would prompt me for a password if I signed in as root. So I'm going to sign in automatically. No password needed. So now I can do something like I can run a command, cat etc password. So I'm going to go back up. Am I still connected to VM1? Yes. So this is going to connect to VM2, run a command, then disconnect again. Before, if I don't supply a command, it connects me to the server and keeps me connected. But if I supply a command after the connection command, it will run that command and disconnect immediately. So let's do this. Let's do the command hostname. So it's going to connect to VM2 as student, run the command hostname, then disconnect. So look, I'm still back on VM1. So I can do stuff like this, embed this in a script, and it'll automatically happen without me having to be there. So I'm going to connect SSH student at VM2. So I'm going to connect to the other machine. Now I'm connected. I'm going to SU as root. So I connected a student, then SU'd as root. So guys, here's something that you should never use root account to connect remotely. On the remote, I don't care what you are locally, but when you connect remotely, never use the root account on the remote machine. Always sign in as a non-privileged user and then SU as root if you need to. By default, it allows you to do that, but you can easily stop that. And I'm going to show you that in a few minutes. But I want to go over some other things first. I'm going to run a command called yum list. I'm going to grep for SSH. It's giving you a lot of feedback, but I just want to find right here. So guys, basically the package that we're using, anyone can create their own SSH server, but Red Hat is using the open SSH software, which is probably the most common SSH server out there. Anyone can make their own SSH server. It has a component called OpenSSH client and a part called OpenSSH server. So on VM1, we were using the client. On VM2, we're using the server. So I didn't have to install the software or configure it at all. It was basically pre-installed. Guys, server software, just like Chrome, Chrome is a piece of software, and this OpenSSH server is just a piece of software. And when we want to use Chrome, we have to launch it. Meaning, basically, once it's installed, if you want to use that software, you have to click the button to run that software. Well, this SSH server software is going to run in the background, and when someone connects to port 22 TCP, that's the port that SSH server listens on, that software will allow you to make that connection and pass your remote commands. Now, this software, OpenSSH server, has to run at boot. So we have this special set of commands that allow me to run a particular piece of software automatically at boot. And it's called system control. I'm going to do status. Open, I believe it's called OpenSSH. Let's see. I don't know what it's called. Okay, they're calling it SSHD for daemon. That's the OpenSSH server. So I'm going to hit the Q key to get out of this. So this command, system control status OpenSSH, showed me the status of that software. So when I boot up, it automatically runs the SSHD software. When you install it, it automatically configures this for me. But some services doesn't configure this. You might mainly have to tell the system to automatically run a piece of software. So if you install a web server, it doesn't start that web server automatically at boot. You have to manually use this system control SSH command, system control command to make it run at boot. So if I want the software to run at boot, I would type system control enable SSHD. So now from this point on, every time I reboot the system, the SSHD will automatically start. If I do this, now when I boot up VM2, the SSH server won't run. I don't want that, so I want to enable that. I want that software to, sorry. This keyboard is so weird. Okay, so the SSHD software will now run at boot. If I wanted to stop or start a service because it's messing up or something, I can do, start. I'm going to get an error because it's already running. Or stop. I don't want to do this because I'm using it right now to connect. I don't want to disconnect from my VM2. But this is like a little bit of an overview of how to look at the status of the OpenSSH server. Not only does it show me it's running, it also shows me any events that have happened, anything from my log files. I can enable it so it turns on at boot. I could disable it so it doesn't turn on at boot. I can run system control stop to stop the service, or system control start to start the service, or system control restart. This might not disconnect me. Let's see if this will disconnect me. No, it didn't. That will stop and restart the service. So this will allow me to control that SSH server. I just wanted to point this out. We didn't have to do anything for this because it's automatically done when we installed the operating system. It automatically installed OpenSSH and automatically had to come on at boot. Okay, the last thing I want to show you guys is the configuration file for SSH. I have an SSH client and an SSH server on this machine. So I'm going to cat sorry guys, I'm hitting double tab. So I say cat etc SSH, that's a folder. In that folder is a bunch of files. Sorry, all these are the files in that folder. It wasn't responding, so I hit tab too many times. That's why it came up like this. So if I do cat and in a folder, then I hit tab, it will show me everything in that folder before it allows me to move on with the command. So it was kind of a quick way to look what files were in that folder. So these are all the configuration files for SSH. I have an SSH underscore config file. That is for my SSH client. I have an SSHD underscore config file. That's the configuration file for my SSH server. Because when I installed OpenSSH, it installed both the client software and the server. So I could use VM2 as a client if I wanted to, but right now I'm just using it as a server. And the first time you boot up that server, it automatically creates keys. It creates RSA keys, ED keys, I'm not sure what type of encryption technology that is, and these ECD SA keys. So basically, it did 3 sets of keys. A private key and a public key for this encryption technology. A private key and a public key for this encryption technology. And a private key and a public key for RSA. So this is where all my configuration files and my public and private keys for my server are stored. So when I connected remotely, it gave me SSH client and the SSH server negotiated the strongest encryption method possible. And at that point, it gave me the public key for that encryption method. And I can't remember which one we used. I believe it was this. I believe this was the key that it sent me automatically. So the first time I connect remotely, it will prompt me to save my public key. So I'm going to go into the SSH configuration file for my SSH server. So I'm going to do vi etc ssh sshd underscore config. Now, I don't know if you remember vi, but I'm going to do a search. I'm in normal mode. I'm hitting the backslash. I'm doing a search for permit root, and just do a search for permit root. And it searched through the file, and I have this line, permit root login. Right now, it's allowing me to sign in remotely using the root account. So I can sign in as SSH root at VM2. In really secure environments, you don't want to allow that, because if the root account gets compromised, you might as well redo that whole box, because you don't know what they've done. So you might want to avoid allowing people to sign in as root. So I'm going to hit Shift A to edit this file and say no, because I want to force people to sign in as a non-privileged user account like student, and then once they're logged in, if they want to go as root, they can SU space hyphen to sign in as root. The other thing that you might want to do is prevent users from signing in with passwords. You want to force every user to sign in with keys. So right now I'm going to do, I hit escape. After I change this to no, I hit escape to go back in normal mode. Then I hit backslash and do password A for password authentication. I'm searching for it. So right now, it's allowing me to sign in with passwords. That's the default behavior. But if I wanted to, I want to force everyone to use keys, I can go down here, do a Shift A, and say no. And so basically, that right there will force all user accounts to use keys. If someone is trying to do a hack on your system, they're trying to log in remotely, trying to sign in as a root user account, and they're going to try a bunch of brute force passwords, it'll never work because we're not accepting any passwords whatsoever. So if you don't have a key, I'm not going to sign you in at all. So right now, I changed my configuration file so you can't sign in as root, and you cannot connect with a password. You have to use a public and private key pair. So I'm going to press escape, then colon WQ to get out and save my work. Now I'm going to use system control, and some servers have this reload utility that will reload the configuration file. If the utility that you're using doesn't, if the service you're using doesn't have reload, you might have to do a restart. Because when I make a file to the configuration file, the server's not going to know that a change has been made, because when I booted up this machine, it read the configuration file. So it uses those settings. If I make a change to the configuration file, it doesn't know I made a change until I restart the service, or if the service allows it to reload the configuration file. So now it should know about those new settings that I've done. So I'm going to disconnect from the server and try to reconnect. So first I'm going to try to, sorry, I'm still signed in to the server. I signed out as root. Now I'm going to remotely disconnect from the server. Because remember, I connected as student, then SU'd as root. So when I type exit, I exit out of root. Now I'm exiting out of student. So I'm back on VM1. I'm going to try this. SSH root at VM2. It's not going to allow me to sign in as root at all. So I'm going to try this SSH. I'm just going to use a fake account. No, actually, I want to do this. I'm going to SU as student locally. No, actually, I'm just going to type exit. So I'm signed in as student on VM1. Remember, I didn't create any keys for student. So list.ssh. The directory doesn't exist because I'm never connected to another server as student remotely. So I'm going to do on from VM1. So my student account on VM1 has never connected to a server. So I'm going to try to SSH, nor did I create any keys. Student. So I'm going to try to connect to the student account on VM2. It's going to ask me to save the public key because this is the first time as student on VM1 I'm connecting to that server. And it denied me because I did not create any public-private keys for my local student account. For this account on VM1, I didn't create any public keys. Remember that SSH Key Jen command? I never did that for student 1. Now here's the thing, guys. I would have to copy that key over manually at this point because I'm no longer allowing anyone to sign in with the password. So I can't, let's see if it'll work. So I'm going to do SSH Key Jen to generate a key. So I've created a keys, public and private keys for student on VM1. So if I do a list.ssh, I now have a public and private key. Since I've connected to the server once and I saved the public key for the server, I now have a known host file. So let's see if I can copy the key over to the server. I'm going to copy the student public key from VM1 to the student account on VM2. I don't think it's going to work because this account right now doesn't know about my public key. And this server doesn't allow me to sign in with my password to send over my public key. Yeah, so I would have to connect to the server as another account, relax the permission so I can sign in with the password, and at that point it will allow me to copy over my public key. Or I put the public key on a thumb drive and carry it over to the server manually. However you want to do it. But once you make that change so no one can sign in with the password, they will not be able to create any keys from that point on. You wouldn't be able to copy any more keys over from that point on using your password. So, guys, this is a very important topic. This is how we remotely configure servers. A lot of the servers that we're using have no graphic interface. They're on a rack in some sort of wire closet. So you need to be very familiar of how SSH works. It's probably the most used service on a Linux box. Every Linux server automatically has it installed. Ubuntu that you download, the Ubuntu desktop doesn't have it installed, but you can easily install it, and it works the same as that I'm showing you here. So Ubuntu desktop doesn't have it installed by default, but pretty much if you use Ubuntu server, it will be there. Okay, guys, that's it for this video. I know it was a long video. I know it's a very confusing topic. So read the chapter. It is chapter 10 in the first book. Also, read about public key infrastructure, so that's really important. And that's it for this video. I'm going to try to do the next video here in a few minutes. Thank you.